So sample problem 5.4, as we'll see, is going to be another changing variable problem, but it's kind of set up a little differently, and it might not be easy to see at first why it's a changing variable problem, or specifically what we need to think about for it to be a changing variable problem. I like to draw pictures. I'm a very visual learner, so sometimes that helps me think about kind of what's going on. So we're talking about having a blimp here, and so if we think about the information that's provided in the problem here, the scale model of the blimp is going to rise when it's filled with helium to a volume of 55 decimeters cubed. So here I'm going to have my little blimp. I know it looks like a muffin, but it's a blimp here. And so we need to have a volume of 55 decimeters cubed for it to rise. So again, this is what we need. Let's talk about what we have. So what we have is we've got a little blimp here, okay, and we've added, so we have 1.10 moles of helium that's in there. That's going to make the volume equal to 26.2 decimeters cubed, but at this point it's still not rising. So the question is, how many more grams of helium do we need to add in order to get to this volume and have our blimp rise? Tells us to assume we're at constant temperature and pressure, but hopefully what we see here is we're going to have a situation which is a changing variable problem. Okay, we need to see what we need to do to get to a volume of 55 decimeters cubed. Again, we're going to have volume and temperature, or volume and quantity changing. So when we're doing one of these changing variable problems, we've got P1 V1 over N1 T1 equals P2 V2 over N2 T2. And if you forget kind of how we get to that, go back to sample problem 5.3 and watch how we talked about the conversion of PV equals nRT equal to R, and that's how we get this relationship. To make it a simpler equation, we can cross off what they tell us is constant. So if we assume constant temperature and pressure, that means we can eliminate those from this equation. And this equation simplifies so that volume and quantity are what are going to be proportional. And again, think about this. Think if this makes sense. When we have something in the numerator and something in the denominator, that means these two variables are directly related. If we increase the quantity, that will increase the volume. And so that's what we're really seeing here. We have a certain smaller quantity that has a certain volume. We want to know how much we need to increase that quantity by so we get to a larger volume. So we're going to figure out how much helium we need to add. So essentially what we need to do is we need to solve for N2. We need to solve for how much helium needs to be in there in order for us to increase it. So again, writing down the variables that we have, our first volume is 26.2 decimeters cubed. Our quantity is 1.10 moles of helium. We want our new volume to be 55.0 decimeters cubed. And the question is what number of moles of helium will get us there. And keep in mind, we'll have to do a little bit more work. Just finding the number of moles of helium is not going to be the final answer. They ask us how many more grams of helium do we add. So we'll solve kind of that at the end once we figure out what's the total volume or the total moles of N2 helium that we need to have. All right, so again, solving this for N2, hopefully everybody can follow along here. If we solve for N2, okay, N2 is going to be equal to V2 times N1 over V1. Okay, now one of the things you'll see here is because we're taking a ratio of these two, so the ratio of these, all that needs to happen is that we have these in the same units, okay, because those units will cancel. So those units cancel. We do not have to have, so normally our volume's in liters. Wow, we could go through a whole bunch of unit conversions to get this into liters, but we don't need to do that. Okay, we don't need to convert to liters as long as these are the same units of volume because they're a ratio of one another. Okay, all we need to do is make sure that they are in the same units. Okay, so that's really important and makes our problem a lot simpler than if we had to convert cubic decimeters into liters, although you could do it. All right, so we need to make sure we put our stuff in the right spots. So we've got V2, which is 55.0 decimeters cubed, N1, okay, which is our 1.10 moles, and then V1 is 26.2 decimeters cubed. Like we did before, let's make a prediction. We need to make sure that we understand, again, a direct relationship between quantity and volume. We should get a N2 that is greater than N1. We should increase the number of moles because that will increase the volume. If we didn't, okay, that meant we switched these two volumes, okay, because we would have a smaller number on top and a larger number on the bottom. Okay, this ratio would be less than 1. We would essentially scale down. We would decrease 1.1. Because we have a ratio that's greater than 1 here, it's going to scale up this. So that's consistent with our prediction. So we've got our variables in the right spot. Okay, N2 is going to be equal to 2.31 moles of helium. Now, we don't want to go ahead and circle that and say, wow, I'm done. That's the answer to the problem. That's what we need to get to. We already have 1.1 mole of helium gas there. Okay, so what we need to do here is realize that what we need is 2.31 moles of HE. What we have is 1.01 moles of HE. When we subtract what we need and what we have, we will get what we need to add, which is going to be equal to 1.21 moles of helium. Now that's not even still the end of the problem because they asked us how many grams of helium do we need to add. Well, that's pretty straightforward to convert moles to grams. We can use the molar mass. 1 mole of helium is 4.003 grams of helium, and then that's going to be equal to 4.84 grams of helium to add. And that is the final answer that answers the question. How many more grams of helium must be added? Make sure before you finish a problem that you've thoroughly answered the question that they're asking.